Okay, section 6.8, the objective is to be able to graph inverse trig functions. And your homework's on page 410, 15 to 31 odd. So just reminding at 0, the coordinate point is 1, 0. At pi halves, it's 0, 1. At pi, it's negative 1, 0. So I can graph sine. Graphing sine is easy. That's a little snake, but let me go right here. So at 0, we have 0, 0. At pi halves, we have 0, 1. So I'll say this is at pi. I'm at 0 again. So here's our little snake. We know that sine is going to look like this. So arc sine or inverse sine, arc sine or inverse sine x, it's the same thing, is basically when you're finding the inverse, finding inverse is you switch the x and y and solve for y. So when we're graphing, we're going to switch the x and y. So instead of having x sine x, you would graph sine x, x. So at 0, sine of 0 is 0. So I'd still have 0, 0. But at pi, I would put 0, 1. Well, let's go this way. I'm going to look at this from the point of domain and range. When we do sine, when we have y equals sine, the domain, that's your x values, right? Your x values is all the real numbers. We use all of them. And the range goes from negative 1 to 1. It only goes up to the highest point is 1. The bottom point is negative 1. So if we're going to do y equals sine x, you're going to switch the domain and range. This is all real numbers, and this is negative 1 to 1. Our x's become between negative 1 and 1. So when I go to the graph, I'm just basically switching, and these are going to be, I'll do it down here. So the inverse sine of x, my asymptotes, I'm only going to go, my x is going to go to 1 and to negative 1. Now, remember over here, this point is 0, 0. So here's 0, 0. But over here, this point is at when my x is pi, my sine is 0. So when my x is pi, my sine is 0. My x is pi, my sine is 0. I'm going to flip it. I'm going to do 0 pi. When I go negative pi, I'm also going to get 0. Or when I go negative pi for my x, I'm going to get 0 for sine of x. So this is really, I'm doing sine x comma x for inverse sine. So when we pick our x to be, say, well, I'll just do it so you can see with pi. What is sine of pi? Sine of pi. This is pi. Sine of pi is 0. So it's going to be the inverse, and it's going to look, it's going to hit here and here. And what's happening at 1? What is, when I plug in 1 for my x value, sine of 1 is up here. Sine of 1. Alexa, what's sine of 1? It's 0, right?
The answer to your calculation is 0.173648.
0.17. So it's going to be positive. It's going to look like this. I'll show you a pretty picture. Sine of x, here we know sine of x. The inverse, you just flip the x and the y value. Okay? You just flip the x and the y value. The same thing goes with sine and arcsine. Okay, or cosine and okay, here's the sine of cosine. Notice the domain is all real numbers, and the y doesn't get any bigger between 1 and -1, and it just flips. And then we're going to reverse it. So here this value is pi -1, then I'm going to go -1 pi. This value is 0, 1. I'm going to go 1, 0. I just flip it. And then we talked about tangent in the last video. Okay, this point is pi 0. So when we come here, we're going to go 0 pi. And there's that function right there. This is a much better graph than I could possibly draw. All right? But I could write the inverse functions. Let's do another example. What if we say, write the equation of the inverse function. Then, okay, write the equation. Here's example 1. Write the equation of inverse function. Okay, so let's say we have y equals arc cosine of x. Okay, so to find the inverse, we are going to switch the x and the y. So we're going to get, and I can write this as y equals cosine inverse of x, which is x equals cosine inverse of y. Well, if this is true, then I can just change this to y equals cosine x, right? Or to inverse the inverse of x, this is -1. The inverse function, and you do the inverse function with a -1 of x equals cosine x. Okay, and we go to graph it. Okay, so arc cosine of x is like this. So we're going to have 1, 1, 0. Now, how do I know that? Because arc cosine, when I plug in at 0, cosine is 1. Okay, so at 0, cosine equals 1. So if I'm going to do the arc cosine, I'm going to do 1, 0. I'm going to reverse it. So this is going to be 1, 0. And this is going to be pi. So I'm also going to get -1 pi, -1 negative pi, negative. I'm going to get the graph that looks like this. Again, I'm not the best drawer, but now I'm going to do the inverse of that function. And that inverse gave us cosine. So now we're just going to have cosine. And the cool thing is kind of like you just flip it, right? I'm going to turn this 90 degrees. 90 degrees. Oh, and look, here's my cosine function. So the inverse is 90 degrees. See if it works for this one. This one would go down like this. If I do 90 degrees. Okay, sorry, I went off on a tangent. My class can do that to me. So I'm going to get cosine, which is just going to be this function right here. I'll show you Mr. Early's drawings. Okay, they're a little bit nicer. Our cosine is like this. Notice if I flip it, this is now 1. If I flip it, I just turn it 90 degrees. And here is the inverse. Okay. there's the inverse 90 degree flip. All right, a couple more examples. Hopefully I could get this one done in one video. What if I just use Mr. Early's notes then? Okay, so we're going to go, we have arctangent of 1/2. Again, we're going to switch the x and the y. So this becomes inverse tangent. X equals inverse tangent of 1/2 y. So I can just change that to tangent x of 1/2 y. And now if I want to solve for y, multiply both sides by 2, multiply this side by 2, multiply this side by 2. So y equals 2 tangent x. Y equals 2 tangent x, or f of x, the inverse of the f of negative 1x. The inverse function equals 2 tangent x. Okay, so the original function was arcsine. Okay, here's tangent x. This is 2 tangent x. Okay, this one you guys might have to get a little bit of help at the review. I so apologize. I could do it, but I'm having a hard time explaining it. It's been a long time since I had pre-calculus. Some of this stuff, you learn it this year, and that's it. It doesn't really come back that much in calculus. Let's do another example. Y equals pi halves plus arc sine of x. I'm going to rewrite it. I'm going to change the x and the y. So here's my y, here's my x. I'm going to flip them. And then I'm going to solve. I'm going to flip them. The x comes over here, the y comes over here, and we're going to solve. I'm going to subtract pi halves. So I get sine of negative 1, inverse sine of y equals x minus pi halves. And then remember, if this is inverse sine of y, I could take all of this and just put it in front of sine, and that equals y. Hopefully you remember that, and this is not a new thing, because you should have been able to do inverse sine and cosine before. All right? Then graphing them, you switch the x and the y. So here we have, here's sine of x right here, but it's shifted 1/2 pi. So here we just shifted this over 1/2 pi. Arcsine, we have arcsine right here. You see this? And we shifted it plus 1/2 pi right there. All right? Find each value. How do I find inverse sine of 0? Again, we're going to rewrite it. Inverse sine of 0 equals some theta that we don't know. So we're going to change it to sine of theta equals 0. Basically, we're asking ourselves, at what value or what degree will sine be 0? So we know from the unit circle, and I'll get out my handy dandy unit circle. We know from the unit circle that sine is 0 right here at 0 or at 180 degrees. All right, so 0 and 180. Let's look at inverse tangent of sine of pi halves. First of all, let's figure out what sine of pi halves is. Sine of pi halves, that's going to be at 90 degrees. Sine at pi halves is 1. Okay, so really this becomes inverse tangent of 1. Inverse tangent of 1 equals theta, so we can flip it. Tangent theta equals 1. Well, what angles are tangent equal to 1? Remember, that's where sine and cosine are equal to each other, or x and y have to be the same. So from our unit circle, we know it's 45 degrees and 225 degrees. One last example. If I can squeeze it in. 40 seconds before the camera ends. Arc sine tangent radical, cosine of arc tangent radical 3 minus sine arc sine radical 3 over 2. So we're going to have to rewrite this of tangent, inverse tangent 3, blah, blah, blah. You got this. We're going to do substitution. All right, I'm not going to be able to finish this one before the video. So I'm going to let it be there so you can pause the video and get that information. I will see you on the field trip.